Today's topic that we're going to discuss is the atomic structure, and specifically today we're going to talk about isotopes. First, just want to give you a little bit of an outline. We're going to talk and review what we talked about last lecture about three main subatomic particles that are found in the atom. We're going to define the atomic number and mass number, two important terms you have to know. And we're going to, as I said, discuss and define isotopes, and we'll do several examples like we always do. Remember, last lecture we discussed three types of subatomic particles. These aren't the only types of subatomic particles, but they're the ones that we're going to focus on in this chemistry class. The first of these is proton. Remember, we said that a proton has a positive charge and can be found in the nucleus. We said that a neutron has a neutral charge or no charge and can be found also in the nucleus. We also said that an electron has a negative charge, and for now we'll just say that the electron is found someplace outside the nucleus in what we'll refer to as the electron cloud. And the electrons are much smaller in mass than either the protons or the neutrons. But the important thing to remember is that the charge of the proton is equal to the charge of the electron, so that we can create neutral atoms by having equal number of protons and electrons. We also discussed Rutherford's gold foil experiment. And remember, in this experiment he had a radioactive element, radium, which was decaying and ejecting these alpha particles. So here comes your stream of alpha particles, and if you remember, he passed his alpha particles through this sheet of gold foil. He found, to his great surprise, that a great number of these alpha particles were actually deflected back through large angles here and would be detected by his detector over here. This led him to know, or to believe, that there was a region of immense density at the center of the atoms. Okay, because remember, most of the alpha particles passed through the gold foil sheet undetected, or some were slightly scattered. But the fact that some of these were scattered and obstructed in their path means that the region of immense density at the center of the atom, and we called this the nucleus. Now, if we were actually to zoom in and look at this cartoon depiction of an atom, we would find here that we have two protons, if you count the red spheres in the middle in the nucleus, and we also have two neutrons. We have two electrons, and this is just a coincidence. These guys in principle don't have to be equal to each other. There's no reason they should. But we do see that the number of protons is equal to the number of electrons. That tells us we have a neutral atom. And because we have two protons, this, believe it or not, tells us which type of atom we have. We look at the periodic table and we see that helium has an atomic number of 2. So we know that this is a helium atom. This atom is of a different type. It has 3 protons, 4 neutrons, if you count them. Could be obscured a little bit. 3 electrons. So this is also a neutral atom. The protons equal the number of electrons. And notice that this is not a helium atom because it has 3 protons instead of 2. And so what we're finding out is that the number of protons tells you which type of atom that you have. The number of protons is called the atomic number. So the atomic number in this example is 3. And you look on the periodic table and you find that this corresponds to lithium. Now specifically, we can say that this is a lithium 7 atom because the sum of the protons and neutrons is 7. Basically what we're saying is that there's 7 subatomic particles in the nucleus, now called nucleons. So this is lithium 7, and we write it like that. So, a couple important points just to make sure that we emphasize these. The number of protons uniquely identifies an atom. That's the atomic number. There's only one element that has 2 protons, for example, that's helium. And if you don't have 2 protons, you're not helium. The number of protons plus neutrons is called the mass number. And remember, we said we had lithium-7 in the first example. The previous example, if you want to rewind the tape, is helium-4. Okay, so the nucleus always has a positive charge, and we said that the protons and electrons have the same magnitude of charge. Now, as I said, you have to have a certain number of protons if you want to have a certain identity as an atom. But it turns out that the number of neutrons is not terribly important. In fact, here we see 2 distinct types of hydrogen atoms. The hydrogen atom on the left has only 1 proton, but because it has 1 proton, the atomic number is 1. That means you have hydrogen. The atom on the right also has 1 proton, and so also is hydrogen. But notice that the atoms on the left and the right, they are similar in identity, or the same in identity, but they have different mass numbers. The sum of the protons plus neutrons on the left is 1, so this is hydrogen 1. On the right hand side we have hydrogen 2, because this hydrogen atom also has a neutron. So this is hydrogen 2. And so we see that these 2 hydrogen atoms, contrary to what Dalton had supposed, are not exactly identical in every way. In fact, they're going to have a different mass. They're going to behave the same chemically, just going to have different masses. This case here in the previous slide, where we had hydrogen 1 and versus hydrogen 2, is the first case that we are seeing of isotopes. Isotopes are 2 atoms such as these that have the same number of protons but differ in the number of neutrons that they have. And this is a key point here to remember, is that the identity of the atom is not changed, it's only the mass. Alright, let's show you how this works, and let's look at 2 other isotopes here. Here we have carbon-12 and carbon-13. Notice you can write it here like this with the dash, or you can also write it as I've done on the previous screen with the superscript here, 12 and carbon-13. So these 2 atoms will have different masses, but they're both carbon. What does that tell us? They each are going to have 6 protons. So we can write the number of protons, or the atomic number, down here to the lower left. We oftentimes don't write it because 6 protons, if I tell you the atom has 6 protons and I tell you it's carbon, this is redundant. So we don't really need to specify this, but we can if we want to. So we know that the number of protons is equal to 6 in each case. We also know the mass number that was given to us. So we know that this case we must have 6 neutrons, because 6 plus 6 equals the mass number 12. And in this case we know that we must have 7 neutrons, because 7 plus 6 is 13. So if you tell me the mass number and tell me which type of element it is, I can tell you how many protons, how many neutrons, and describe the nucleus. Alright, let's do another example. In this case I tell you that an atom has 13 protons and 14 neutrons. What type of element is it, and what is the mass number? In order to identify the atom, all we have to do is look at the periodic table. We find an element with the atomic number 13, and we know that that is aluminum. The second question about the mass number, well, remember the mass number can be found by taking the number of protons and the number of neutrons and summing them up, and we get 27. So this atom is aluminum 27. Okay, how about this? Identify this element. This element's telling us it has a mass number of 9 and an atomic number of 4. So we look on the periodic table, we find an element whose atomic number is 4. It turns out this is beryllium. And we can even specify, say, beryllium 9 if we want to. We can put the atomic number down here. But again, not typically done. How about this question? How many neutrons are found in neon 22? So in order to answer this question, we need to look at the periodic table. We find that neon has 10 protons, so therefore it must have 12 neutrons. That's the answer to the question. How many electrons are found in a neutral lead atom? If we want to answer this question, we need to remember that electrons have a negative charge, and they serve to cancel out the positive charge that's on the nucleus. So the positive charge is on the nucleus, the negative charge is in the electron cloud. We know from the periodic table that lead has 82 protons, so if it's neutral, it must then also have 82 electrons. How about this last question? I tell you that an atom has a mass number of 36, and then I ask you to identify it. Well, this is a trick question, because remember, if I tell you the mass number, you cannot uniquely identify an atom simply by its mass number. You must have the atomic number, and in this case, this is a trick question. We have to know the atomic number. The mass number, turns out, doesn't help us identify the atom in most cases. Alright, so just to give you a quick summary of what we've talked about today, we reviewed the 3 subatomic particles. We defined the terms atomic number and mass number, and we did many examples using our knowledge of isotopes. Thanks for watching the video, and I'll see you next time.